Now that we have a good intuitive understanding of what the operators in the logic CTL mean, it is time to be more precise and give the formal definition. It starts with being precise about the syntax. It is traditional to have one set of formulae that tell properties of states called the state formulae, and we use the Greek letter phi for that. And another set of formulae that talk about what holds on paths, and we use the Greek letter psi for that. Looking at the state formulae, the BNF syntax tells us that it can be an atomic proposition. It can be the existence operator of a path that satisfies a path formula psi. Or it can be the all operator saying that for all paths, the path formula psi must hold. It can be the negation of a state formula, a conjunction, and other logical operators applied to it. For path formulae, we have the X operator telling us what will happen in the state that is next in the path, the F operator that says what will happen at some point on the path, the G operator that tells us what must hold for every state in the path, and a new operator U that we'll explain in just a moment. Now for the semantics of a state formula phi with respect to a state var sigma. The atomic proposition AP holds in the state if it is one of the labels being assigned to that state. The formula E of psi holds if there is a path that starts at var sigma for which this path formula holds. The formula A of phi holds on the state if all the paths that emanate from the state var sigma satisfy the property psi. Negation holds if the formula doesn't hold, conjunction holds if both formulae hold, and so on and so forth. For the semantics of path formulae, we need a path pi, starting with a state var sigma 0 and going on. The formula x of phi holds in such a state if the state that is next on the path, namely var sigma 1, satisfies the property phi, and indeed that the path is long enough to have such a state. The formula f of phi holds on pi if there is one state on that path, var sigma n, where the formula phi holds. The formula g phi holds on the path if each and every state on the path satisfies phi. And finally, there is the new operator phi 1 until phi 2. It holds on a path if we can find an index n such that the state var sigma of n satisfies phi 2, that is the formula to the right of the u, and all the states before that state satisfy the formula phi 1, that is to the left. But note that it is possible to choose n being 0, so if phi 2 holds on the very first state of the path pi, then the formula is still true. Now it's time to read the explanation in the book, doing the try-it-outs on the way.